Solid Geometry, Chapter Sphere, in exercise 6.5. Intersection of a straight line and a sphere. Equation of a straight line. X minus x1 by L, y minus y1 by M, z minus z1 by N. And equation of a sphere. X square plus y square plus z square is equal to a square. From this straight line, we find out the point of the line which intersect at a sphere. X minus x1 by L, y minus y1 by M, z minus z1 by N is equal to k. K is any constant. Point of a straight line. X minus x1 by L is equal to k. Then x is equal to lk plus x1 plus lk. Y is equal to mk plus y1. Z is equal to nk plus z1. When this straight line cut the sphere, this is the point of intersection of the straight line and sphere. So we put this point P in the equation of a sphere. X square plus y square plus z square is equal to a square. X is equal to then x1 plus lk square y1 plus mk square z1 plus nk square is equal to a square. Here we find out the equation in the second degree of k. Terms of k square, L square plus M square plus N square plus 2k Lx1 My1 Nz1 Lx1 plus My1 plus Nz1 plus x1 square plus y1 square plus z1 square, and this a square minus a square. This is the equation of second degree in k square. This equation gives two values of k, k1 and k2. If these two values are different, which shows that this straight line cut the sphere at 2 points, and these both values are same when k1 is equal to k2. This shows that this straight line touch the sphere at the point 1 point P, and this straight line does not touch the sphere. This shows that both values are imaginary, not real values, which shows that straight line not cut the sphere. Now we find out the length of tangent from the point P alpha beta gamma to the sphere. X square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. This is the equation of sphere, and the center of this sphere minus u minus v minus w. P is the point outside the sphere. This is the sphere P point. We find out the length of tangent line which touch the sphere at a single point outside the sphere. We find out this length Pt. This is the center of the sphere, minus u minus v minus w. This is the radius of the sphere. This is the length from the point P to C. We find out this length. CT is the radius of the sphere. Radius of the sphere, u square plus v square plus w square minus d under root. PC is the length between 2 points. We find out this length by distance formula, P to C. Then alpha minus u, alpha plus u square. Beta minus v, beta plus v plus gamma plus w square under root. We know that this radius CT makes right angle at the tangent line. Then we use right angle triangle formula. Right angle triangle PTC. Then by Pythagoras rule, PT square is equal to PC square minus CT square is equal to alpha plus u square plus beta plus v square plus gamma plus w square minus u square plus v square plus w square minus d. We solve this equation. We find out alpha square plus beta square plus gamma square plus 2u alpha plus 2w 2v beta plus 2w gamma plus d. Now PT is the length of tangent from P alpha beta gamma to the sphere, which is equal to alpha square plus beta square plus gamma square plus 2u alpha plus 2v beta plus 2w gamma plus d under root. Here length of PT greater than 0, then point P is outside of the sphere. And PT is equal to 0. This length is equal to 0. Then point P lie on the sphere, lie on the boundary of sphere. Now, power of a point with respect to sphere. If a straight line which is drawn from P cut the sphere at 2 points Q and R, then the distance PQ PR is equal to constant. Then this point P point is called the power of point P with respect to sphere. If from a given point P a line is drawn intersecting given sphere at point Q and R such that PQ PR is equal to constant, then PQ PR is called the power of P. This is the power of P with respect to the sphere. When we find out PQ dot PR, which is equal to alpha square plus beta square plus gamma square plus 2u alpha plus 2v beta plus 2w gamma plus d. This is the power of P. Now example. Find the coordinate of the point in which the line, this is the line, meets this sphere. Now we take the equation of a straight line x plus 2 by 4, y plus 9 by 3, z minus 8 by minus 5 is equal to k constant. Now we find x is equal to 4k minus 2, y is equal to 3k minus 9, and z is equal to minus 5k plus 8. This straight line intersect the sphere. Then this point lie on the sphere. We put this point on the sphere. Point P. 4k minus 2, 3k minus 9, minus 5k plus 8 lie on the sphere. Then 4k minus 2 square plus 3k minus 9 square plus minus 5k plus 8 square is equal to 49. This is the equation of second degree in k. After solving this equation, we find out 50k square minus 150k plus 100 is equal to 0. This is equal to k square minus 3k plus 2 is equal to 0, which gives two values of k, 1 and 2. These are two different values of k. Then this straight line cuts the sphere at 2 points. 2 points when put the value k is equal to 1 in this point. Then find out the point P and put the value k is equal to 2 in this point. We find out the value of q. So the point P is equal to, when k is equal to 1 in this point, then we find out 2 minus 6, 3. When k is equal to 2, put in this point, then q is equal to 6 minus 3 minus 2. Now we find out the example. Find the locus of the center of the spheres which passes through a given point and intercept a fixed length of a given line. First we take a given point and a given line. Let the point 0, 0, C on z-axis. We can take this point on also x-axis and y-axis, a0, 0 or 0, b, 0. Here we take the point 0, 0, C on the z-axis, and given line x-axis. On x-axis y is equal to 0, z is equal to 0. We also take this line as a y-axis and z-axis. Now the equation of sphere. Equation of sphere. X square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. Center of this sphere, minus u minus v minus w. And this sphere first passes through the point 0, 0, C. Then equation. Sphere first passes through the point 0, 0, C. Then equation becomes c square plus 2wc plus d is equal to 0. Also sphere meet the x-axis. Where y is equal to 0, z is equal to 0. Meet the x-axis. Then equation of sphere. X square plus 2ux plus d is equal to 0. This is the second degree equation in x. Second degree x. Here sum of roots. x1 plus x2. Equation of second degree. These give two roots, x1 and x2. Then sum minus b by a. Minus b by a means minus 2u. And product of roots c by a, then is equal to d. Sphere intercept a fixed length on given line. Given line is x-axis. Then fixed length on x-axis. Roots are x1 and x2. Roots are on x-axis. Then fixed length, intercept a fixed length on given line, intercept a fixed length on a x-axis, then fixed length x2 minus x1 is equal to 2k constant. This is the fixed length on x-axis between two roots. We have no values of x2 minus x1. For solving this, we take the help of x1 plus x2 into x1 x2. Then x1 plus x2 square minus 4x1 x2 under root. This, after solving this, we find out x2 minus x1 is equal to 2k. For solving this, we take the help of sum of roots and product of roots. Sum of roots minus 2u, minus 2u square 4u square minus 4 x1 into x2 d is equal to, we take the under root on another side, then 4k square u square minus d is equal to k square. Now eliminating d from this equation and this equation. This is the second equation. This is the third equation. Here we find out d is equal to u square minus k square and put this value of d in equation second. C square 2wc plus u square minus k square is equal to 0. Then the equation u square plus 2wc plus c square minus k square is equal to 0. Then the locus of center, center minus u minus v minus w is, locus is, this is the, now this equation is in general equation. U square becomes x square plus 2wc wz 2cz plus c square minus k square is equal to 0. This is the locus of the center of sphere. Locus of the center of the sphere. Now this is the locus of the center of a sphere. Then u and w are coordinate of center and we find out the locus of the center. Then u becomes x, w becomes z.